All right. Can I get someone to check in? Are you all still there? Can you hear me okay? Let me go back here. Hello, hello. All right. Okay. All right. Are you all there? Can you hear me? Okay, cool. So we're back. It's just about that time. We got about 10 seconds actually, and then we're gonna pop it off. So I created a new link. Matter of fact, let me I need some sleep. My brain hurts. Uh give me a moment. Right here. I'm gonna share this link. So if anybody didn't see it, let me share and copy. And I'll load it right here. Okay, good. That's not showing there. Okay. So I just loaded a link for the current session on YouTube. So we're gonna hop over there. Okay. Okay. So I have that as that time. So we took a quick little 15-minute break. I needed it for myself, just to kind of get ready, get going. Let me see if the audio is working here on YouTube. So I just loaded a link for the current. It sounds good, looks good. I ain't gonna worry about it. All right, so we're gonna go ahead and hop into the lecture. I need this guy. And again, if I'm moving too fast or if anything is not clear, you have to just get my attention and we can stop and slow it down and go back. So class doesn't get out until 2:50, so we're just gonna kind of do our best to honor the time. What I'm thinking, so if we have a quiz, we'll have a quiz this week. I will post a quiz on Pearson, and then our first exam will be next Thursday, right? I'll probably make it available at the start of class, and I'm okay with. I'm trying to think about when I want to do it. I'm okay, honestly, with making that quiz due Saturday at 11:59. That exam, I'm okay with giving you a little bit of time to work on it, right? So, but I'll open it up. I'll have it where it starts next Thursday. It'll be over the first half of chapter 1. Okay, so the sections 1, 1, 2, 1, 3, and 1, 4. Today, honestly, we should be able to get through these today. So let's see. We'll see what it's looking like. We'll definitely get through at least 2 sections. If we don't finish today, we'll definitely finish on Tuesday, and then exam 1 is Thursday of next week. Okay. So if anything is not clear or any kind of concerns, just stop me and we can talk about it. But otherwise, I'm gonna press on. All right. Oh, come on. There you go. Looking good. All right. So let's get started with the lecture. I guess I could put you there. We're gonna kind of go like that. Like that. I guess it's fine. I think it's okay. Ouch, my head. Oh, those paintings behind me, by the way, I actually painted those. All that artwork that you see behind me, I did all that. I went to like a painted sip, and that's just how it came out. It was like, they kind of walk you through it, but then everybody does their own presentation or whatever. So that was a lot of fun. I enjoyed that. But anyway, that's neither here nor there. Just trying to get my wires in order. All right. Okay, so let's take a look at this this material. So this is going to be college algebra. We're going to start with chapter 1, equations and inequalities. Okay. Can I get a roll call really quick just to see who's here? Can I get some last names? Did y'all ever have anybody on the team? Have you ever done the roll call song? Y'all know how to do that song? Anybody there? Can you hear me?
Roll call song?
Yeah, it kind of goes like, okay, so when I was in football in high school, it kind of went like this. It was like Saints, Saint, roll call, Saint, roll call. My name is Pfeiffer. Yeah, I'm your instructor. Yeah, we doing this hard. Yeah, we're gonna go. Whatever, something like that. Roll call, Saint. Say. Can we get like a roll call, something like that, or something? Work on that, cause I need. Y'all know that? Y'all ever heard anything like that? I almost got it. I almost got to the end, but that's a roll call. So I just want to know who's here and like who's present, and just to kind of send some energy out and back. You know what I mean? So work on that. We'll try that next time, huh? Do y'all have anything like that? Y'all do anything like that at all? No. No, it's okay. No. All right. I just needed to kind of make sure you all are there and that we can kind of talk back and forth. I can get some feedback. So that's all. Okay. Anyway. All right. So moving forward. Okay. So let's go ahead and keep moving. So this is going to be section 1.1, linear equations. Again, if I'm talking too fast or if anything is whatever, just get my attention and we can adjust the rhythm. But if you're silent, then I'm going to keep powering through, right? So you have to kind of, just ask and, we'll make sure that you're taken care of. So section 1.1 is on linear equations, and some objectives. We're going to talk about basic terminology of equations, linear equations, identities, conditional equation and contradictions, and solving for a specified variable. Okay, so I'm going to be asking a lot of questions, so you kind of got to be ready with your mute. And I'm kind of paying attention. Just say your last name whenever you kind of get attendance. Announce yourself so I know who I'm talking to, and but I'm trying to make it as interactive as possible. So I'm going to be asking a lot of questions. I have been deemed an asshole because I ask a lot of questions. Okay. All right. So can somebody tell me what is the difference between, or like, if you see something like, how can you identify an expression as an equation? What symbol makes you know that it's an equation? What symbol does it have?
Is it an equal sign?
It has an equal sign. So equations have equal signs and algebraic expressions don't. So if you see like the formulas and things and it doesn't have any equal sign, we call that an algebraic expression. So the next question is, if you have an equation, can we solve an equation or do we simplify equations? Oh, and again, be sure to announce yourself so I know who I'm speaking to.
Kempson,
Mr. Kempson. We can solve equations. Okay. So equations have equal signs, and if it's solvable, we can solve it. Algebraic expressions don't have equal signs. Can we solve or simplify an algebraic expression?
Yes.
No, that was one or the other. So can we solve or can we simplify an algebraic expression?
Wait, repeat that again. You kind of broke up.
So remember, equations we can solve, right? Solving an equation means that we'll finish with something like x equals 3 or, x equals 5 or whatever. But with an algebraic expression, can we solve it or can we only simplify it?
I think you're supposed to simplify it.
There it is. Go with your intuition. You do know. So yeah, that's correct. Algebraic expressions, we don't solve algebraic expressions, we simplify. So let's see what we mean by this. So an equation is a statement that two expressions are equal, right? So notice that all of these expressions, They all have the equal symbol, so these are equations. To solve an equation means to find all the numbers that make an equation a true statement. These are what we call solutions or roots. Okay, a number that is a solution, let me go like this. A number that is a solution is said to satisfy the equation. Okay, I'm going to let that be. All right. Stop me if you have any questions. Oh, they've done some changes. I'm excited about these changes. So now this is the first property. We're going to be, okay, other than Mr. Kempson, can I get somebody else to just read through this property for me before I start picking on somebody? So other than, you said Mr. Kempson? Is that right? Am I saying that right?
Yes, you're saying it right.
Okay, other than Mr. Kempson, can I get someone else to just read this slide for me?
Ray?
Mr. Ray, okay.
You want me to read this where it says addition, multiplication, properties of equality?
Yes, sir.
Alright, let A, B, and C represent real numbers. If A equals B, then A plus C equals B plus C. That is the same number may be added to each side of an equation without changing the solution set.
Okay, that was fantastic. Can somebody explain this slide in their own words? Like, what does this mean to you? Like, when you see this, it says that if A, B, and C are real numbers, it says that if A is equal to B, then A plus C equals B plus C. What does this property mean to somebody? Like, what's the difference between the left part of this and the right part? Ooh.
It kind of looks like inverse to me.
Okay, so this my app has updated, and so they have a new, let me see if it's going to show. It's kind of a lag, but that's okay. All right, so it has a new feature. That's what's up. Okay, so this is the addition property of equality. So if we start with one thing equal to another, what do we do on both sides and preserve equality? What did we do? What was the change?
What we do to one side, we do to the other?
Right, we can essentially add the same real number to both sides of the equation and preserve equality. So, right, so this is the addition property of equality. So again, what this slide is saying, we can add the same number on both sides of the equation and it'll preserve the equality. Okay, so if this is the addition property of equality, do you think that there is a subtraction property of equality?
Yes.
What do you think might be the case for subtraction?
You're just subtracting on both sides?
Will it preserve equality? Just go with your intuition. What does your gut say?
Sometimes.
If you're saying sometimes, can you think of an example where it doesn't preserve equality?
Like where one side may be 7 and the other side may be 3, then they're not equal.
So remember, the premise is that at the start they have to start equal. So if the idea is that can we subtract, if we start with them being equal and we subtract the same thing from both sides, will it preserve the equality? And part of me feels like your intuition was kind of I don't want to put words in your mouth, but there's not really a subtraction property of equality, but actually subtraction is another form of addition. So like for instance, what I mean is like let's do it like this. Say we had 5. Oh, that's not gonna work. Let's go like this one. Maybe it's usually that one. Let's see. Say we had 5 minus 3. Is there a way to rewrite subtraction as addition? Do we have a way to rewrite the subtraction as addition?
Hold on. The YouTube is kind of moving a little, so let me just. 5 minus 3. Okay, hold on. Just now seeing it.
Yeah.
To rewrite it.
Pardon?
We're supposed to rewrite it?
Yeah, is there a way to rewrite subtraction as addition?
Make the 5 a negative?
Close. So that negative is going to shift to the right. It's going to kind of go from where it is to the right. All right, okay. So what's going to happen is this is the same as 5 plus negative 3. All right. So we can actually rewrite subtraction as addition, and then once we rewrite subtraction as addition, we can just apply the addition rule. So this does hold for subtraction. Does that make sense?
Somewhat.
So there's not an exclusive subtraction property of equality, but we can always rewrite subtraction as addition, and then we can still do the addition property of equality. So
I see it now.
yeah. Okay. Yeah, I know it's kind of weird, but that's what it is. Okay. So we talked about addition property of equality, and we talked about how to rewrite subtraction as addition. So what do you think is the next one? We did addition, we did subtraction. Which one do you think is next?
Multiplication.
Okay, so if the addition property of equality says that we can add the same real number on either side and preserve equality, what do you think the multiplication property of equality says?
That we can multiply on each side.
Okay, I can get down with that. Can you think of a number where that might not work if we do multiplication?
0?
0, right? So that's exactly what it says. So let's look at the next one. So the multiplication property of equality, now we're gonna pick on someone. Who's in attendance? Let's see. Miss Akbar, are you there? Miss Akbar? Oh. Mr. Ray, are you there? Okay. So, what was I gonna ask? I lost my train of thought. Okay. Well, I'm gonna let it be for now. So, again, so the multiplication property, that's exactly what it says. If A and B are equal, and as long as C is not 0, then we can multiply the same non-zero number on both sides of the equation and preserve equality. So, and then the last question is, what do you think happens with division? Like, do you think this holds for division? Can we divide and it still works?
I don't think so. I don't think so.
So what technique did we use when we had subtraction? What did we do? We did what? We rewrote what?
The equation.
We rewrote subtraction as
addition.
Yeah, we rewrote subtraction as addition. Can we apply that same technique for division? Can we rewrite division as what?
Multiplication.
Okay, let's look at that. So, say we had, what's your two favorite numbers?
2, 6.
Okay. Say we had 6 divided by 2. Say we had 6 divided by 2. Can we rewrite this division as multiplication?
Hold on. I gotta see it first. It's kind of coming up.
Yeah, YouTube is going to be a little bit behind.
So what was the question again?
So we're trying to see, can we apply the same technique of rewriting division as multiplication? If we have 6 divided by 2, can we rewrite that as multiplication?
Well, it would be. I can't think of it.
So 6 divided by 2 is actually the same as 6 times 1/2. Is that okay?
Oh, okay, that makes sense.
So we can, so essentially, as long as C is not 0, we can rewrite division as multiplication. So the multiplication property holds for division as long as C is not 0, because division can be rewritten as multiplication. So we really only have the addition property of equality and the multiplication property of equality, but these two properties are pretty much what we're going to be doing the whole entire quarter. Like, it's just going to be, we're going to pretty much be going back and forth between those two pretty much the entire time. So it's just the addition property of equality and the multiplication property of equality. All right. I'm going to let that be for right now. So this is a linear equation in one variable. It can be written in this form: ax plus b. Do you mind muting your microphone? Yep, appreciate you.
Yeah, I got
A linear equation in one variable is an equation that can be written in this form: ax plus b equal to 0. You might recognize this as like y equals mx plus b. So I'm going to let that be for now. A and b are real numbers where a is not 0. I'm going to come back to some other things there. A linear equation is also called a first degree equation since the highest degree of the variable is 1, right? So the first line are some examples of linear equations. The second line are examples of nonlinear equations. I'm just going to kind of let that be for right now for the sake of time. I want to kind of move on to this. Okay, we're going to try something. We're going to try an activity here. All right, so let's do like this. I'm going to get something to go here. Malachite says she's ready. All right, so let me take that. I'm going to put it here. All right, so what we're going to do, add a page. I need another volunteer. And I mean, honestly, this one could be anybody because this is my first time doing this. I don't really know what to expect. But let me get a volunteer. Let's hop back over to collaborate. So I don't know what to do about that. Let me do, can I close this out somehow? Where's the panel? Okay. And I don't really want to show all that either, but I don't know how to get that gone. Okay, but there is an option. This one. The whiteboard. Okay, what is this? Rectangle ellipse. Let's hide this. That looks good. And then the only thing that I want, if I can figure it out, it's not that one. Is there a way to insert an image? I'll just turn that off for right now.
Another professor, she had her whole PowerPoint on there. I don't know how she did it though.
Yeah, I'm not doing PowerPoint. Yeah, that option is there. If I go here and I share a file, can I just paste it? Can I just do it in the chat? Ooh, I don't want to load that. Let me try it here. Can I just paste it here? No? Paste? Let me save it. I don't think I have anything, but I don't want to show that. Okay, what I'll do like this for right now, just for the sake of, let's go like that. Let's go here. I'm going to share a file, add it. I'm just going to have to let that go and just kind of monitor it. No, I don't want to take a photo though. Library. Let's go to reset, and I think it's this one. Done. Okay. All right. Oh, it's not the right one, is it? See, I'm trying to get, okay. So what I'm trying to do, I'm trying to get this image on the whiteboard. So take a moment to write this down, or you know, take a picture or something. Go ahead and get a copy, and I'm gonna try to hop back over to the whiteboard because I don't know how to get that on there. So what I can do, let's see. All right, so I'm just gonna write a copy of the original. I just gotta pull it back up though. Let me do it like this. Hang on, I'm coming. Okay, so let me just write down a copy of the original. Can we go here? No, there. Okay, that works. And then here. All right, so let me just write it down. Is this, and I will use this color. And I don't need that. I didn't go here. Okay, let me just write a copy and then I'm gonna get rid of this. So it says to solve, we got 3 times 2x minus 4 equals 7 minus x plus 5. Okay, so that's all I was trying to do. Is I was trying to load the image in here, but I couldn't figure that part out. I didn't see where I could paste. Let me see something. Anyway, so let me get a volunteer to write on the white space and see, can you like show us line by line working through this example. Anybody feel up for that challenge? I don't know what kind of device you're on. Anybody have an iPad or a touch device other than the computer? A computer could be a little bit of a challenge. You would need some kind of like, you could try it on your phone.
I don't know though.
Are you already on your phone?
Yeah, I've been on my phone.
So yeah, try to load it and see can you like work this out? Because if you guys can actually write, that would actually be very powerful. That'll be a huge help.
Okay.
And who am I speaking with again?
Huh?
What's your last name again?
Akbar.
It's Akbar. Okay.
Mhm. I don't know if I'm gonna get this right, but let's see.
Okay.
Hold on, let me just test it out, I guess. Okay.
Okay.
Okay. Now to erase.
Yeah, there's an eraser. I don't know if there's an undo though. Undo would be nice. The eraser is at the top.
Hold on.
Oh my bad.
Okay.
Wait, I didn't want to, I did that.
Cool.
And I didn't want to erase all that. I need to undo.
I'm just trying to figure it out, you know?
That's the whole point of all of this. Let me see.
Okay, I'm sorry.
No. I made the mistake. I'm trying to see, can we undo what we just did? There's not an undo button. Let me try.
I don't
this.
see it. All I see is like
A blank page.
a mouse, a pointer.
Yeah.
A pencil. Yeah. I don't see any eraser.
Okay. I'm coming. So let me go back and let me just write it again. So I was looking for an undo, but I couldn't find it. So what I'm gonna do, I'm gonna just write a copy here. So again, the original, this, and I'm gonna go back to this color, and I'm gonna get rid of this. What is this? That's fine. It's fine the way it is. Can I add a page? It's just a whiteboard. Okay, so the original asks us to, can we change it? Solve. It's a solve. We have 3 times 2x minus 4 equals 7 minus x plus 5. Okay, so that's the original. So give it a go and see, can you like show your work on the screen? Just do the best you can. Like,
Alright.
yeah.
Yeah. Okay. Okay, hold on. Let me try to zoom in. Woohoo. Okay.
I think another way to erase is if you select maybe the pencil and then like the white marker, it'll act like an eraser. Because it seems like if you click that erase button, it's gonna erase everything. So I don't know. You just have to kind of just try.
Yeah, it's really small. But something going on. Okay. And excuse because it's really hard to do this with my finger. So I'm just, yeah.
It's okay.
Okay.
No luck?
Hold on. Oh, because it's still white. What am I doing?
It's okay. But it looks good. Like I can see it. And I think I can I can engage too. Like we can kind of be writing at the same time. I'm trying to leave it alone Because I feel like if we're on there at the same time, it'll probably slow it down.
Hmm.
Like what they need is an undo button and ability to change the size. Now, honestly, I think this other app that I'm using, I think they literally just updated it where we can like collaborate, but I haven't had the time to figure it out. I see where you distribute it, so I'm going to make some annotations as you write. I see that initially you did like this, right? And you also distributed the negative here. That looks fantastic. I can see that. Okay.
Yeah. Okay. So I'm trying to figure out, or trying to remember what I do next.
So can somebody chime in and like offer a suggestion as far as the next move?
Yeah.
What, like add on both
Add
sides?
5, right? Okay.
Yeah.
Let's see. I don't know if we can.
Whoa! What did I?
Yeah.
What is that number?
Yeah. I like Miss Hutchins' suggestion. She said combine like terms. Right? So before we use that +5.
Quiet, okay?
Yeah, my dog is doing the same thing, trying to lose her mind. Let me kind of get rid of some stuff as best I can.
Yeah. I gotta rewrite that whole number.
But yeah, I saw combine like terms, right? So before, instead of erasing, let's do like this. Let's do, can we? Does that do anything? Okay. Let's go here. And what I'm going to do, I'm going to strike through it, right? So before we do this step, let's combine like terms. So we have a +7 and a -5. If we say 7 plus -5, what's that going to be? What's 7 plus -5?
Right.
No, just
it'd be 2, right?
2, right? Okay. So I'm gonna, my annotations. So I'm gonna bring down the 12. The 7 plus -5 became a 2. The negative x keeps going. So you should be able to take it from there. So at this point, we can do the whole additive property of equality, right? You should be able to take it from there.
So I'm pretty sure I add the x.
Okay. So what I'm hearing is basically like this. Oh, you got it? You can go ahead.
Yeah, we're not at, yeah.
Okay. So you're saying plus. No, it's me because I'm like rushing you a little bit. It's all good. But yeah, add the x. I will keep going. Keep going. You can go ahead and add the x on both sides.
Yeah, we just gonna consider that added.
Yeah. That was my fault for that part. That's good.
Okay. So I'm thinking this will be a 7, right?
Right, 7x. Let me see. Can we scroll?
Okay.
Hang on. Oh.
Yeah, because I'm running out of space, but we should erase
Oh,
this.
oh wait.
Here at the top.
Okay, we could zoom a little bit. I don't know how to erase. Like I was trying to erase specific things. Can we like cut? Like if we could cut and paste, it has a lot of work and I don't know if it's just us or not. So let me do this as far as annotation. So she combined her like terms. I'm gonna go ahead and add that 12 on both sides too. So I'm gonna go ahead and do this because that was the next part. And then that's gonna give us, so the purple are my annotations. I'm just gonna kind of write it over here. We get 7x on the left equals, what is that, 14 on the right? Does that make sense? Can you finish that out for us?
It should be 7x equals 14.
And then what?
And then you can go over 2. Put it, what, 7 over 7.
Yeah, divide both sides by 7. And then the final result is what? X equals 2. Okay.
2.
So if we're saying that this is the answer, what does this mean in the context of the original? What are we saying? So I'm going to let that be. That was an experience. Matter of fact, what I'm also going to do, I'm going to screenshot this. I'm a screenshot it, and I'm actually going to load it into our notes that we were just doing. I'm going to take like from here, and that's fine. Let's go like this, and I'm actually going to load that over here. So now we're going back to YouTube. Let me drop it right here. Is fine. Cool, that's looking good. And then I'm just gonna blow this up, right? And I'm gonna do it again just to kind of clean it up a little bit because I can do it quick. And again, that was just an experiment just to see, because I knew it had a whiteboard. I was like, okay, well, let's just test it out and see how user-friendly it is. You know, and it was an experience. So what I'm gonna do, I'm just gonna redo this just to have a cleaner copy. Oh, they didn't do it. I thought they finally made it so you can. Anyway, so yeah, we're going back over to YouTube, and I'm gonna kind of keep going from there. So let me just kind of get a clean copy. Okay, and then what I'm gonna do now, I think there's a way for us to collaborate. Let's see if I can figure that out really quickly. Stickies, it's none of those. Okay, I'm not going to worry about that. I had to figure that out later. Okay, let's go here. Where's my paper option? There it is. I'm doing my grid paper. Okay, so let me just get a copy. So we have this it's too big. We have this 3 times 2x. What is that? Ooh, that's better. 3 times 2x minus 4 equals 7 minus x plus 5, right? So I saw where, you know, she distributed her 3 like this. She also distributed the negative here, right? So then the next line we got was 6x minus 12 equals 7 minus x minus 5. Then I think we combined like terms. So the first thing we did is we distributed. Next, what we did, we're going to combine like terms. Combine like terms, right? So on the left, there are no like terms, but on the right, it's the 7 and the 5. So 7 plus negative 5 gives us a 2 there. Let me do this really quickly. Let me kind of go like this. That's fine. Okay. So then the next line, the 7 plus the negative 5 becomes a 2. Everything else just comes down. All right. And then the next thing that we did the additive property of equality. So the property that we introduced today, we want to use the additive property of equality, right? So we added the x on both sides, and we went on and added the 12 on both sides too. I'm kind of skipping steps a little bit here, right? That goes to 0, that goes to 0. 6 plus 1 becomes 7. X equals 14. Then what we did was the multiplication property of equality. And we multiplied both sides by 1 over 7. And that gave us a result of x equals . So when we get an answer like this, the following is what made me fall in love with mathematics. It's story time. So hopefully you're listening. Hopefully you're not too bored or too confused or intimidated. But I intentionally try to throw things in there to just break up the rhythm a bit. But the following story is what made me fall in love with math. I remember being in like high school and college and all these different grade levels. And, you know, I took my work serious. Like, I mean, I was always been lighthearted and kind of goofy, but I took my work serious. And so people could never really figure me out. And that's just how I got by. But like when I would go to like my literature courses, I would do all the work that the professors would suggest. I would like read everything, write the papers. And then I turned in the assignments, and then they give it back. They'd be like, B. And I'm like, why? I did everything that you said, and this is exactly what happened. And they always had some lame excuse to, like, it seemed like they were just messing with me. So, but in mathematics, so, you know, if I get an answer like this, I would say to myself, okay, this is my answer, but I would ask myself, well, what does this mean in the context of the original, right? If we take this number and plug it into the original, what does that mean? Does this make sense? Is this a reasonable answer? If we plug this into the original, what should be the case? What should happen? Should we get a true statement or should we get a false statement? We should get a true statement, right? So I remember having this discussion with myself. So long story short, I fell in love with mathematics because I definitely had teachers that did not like me and they wanted to give me a hard time. But in math, if it's right and every step is justified, they have no choice. They have to give me my points. I mean, it even got to a point where it was in grad school. I did the work and everything I did was right. I just didn't do it the way that the professor liked, and he was mad, but he had to give me the points. He didn't have a choice. So because of that ability of mathematics to check our work, that's what made me fall in love with it. Again, with the literature, I would do the work, do everything, and then they would just give me a B, and they had no real reason. But in math, if everything is legit, even if they don't like it, they don't have a choice. So the ability to check is what made me fall in love with mathematics. So let's do a quick check really quick. So we're going to do a check and say, does this answer make sense in the context of the original? Let me start by getting a copy of the original. And what are we going to do with that answer? What are we going to do with that? Delete. And let's delete that.
Plug it back in.
So when we plug it back in, we, again, like you said a minute ago, we should finish with a true statement. So let's see what happens. And let's go like this. Thank you for chiming in. That helps to keep the pace moving, because otherwise I'm going to sit and we're going to waste a lot of time. But it's okay. I'll make sure I'm monitoring the time. So, you know, it is what it is. So let's plug it in. So now we got x equals 2. Let's plug it into the original and see if it works. So the suggestion, the following is a suggestion. Whenever we do substitutions, we want to replace our x's with a blank set of parentheses. So we're going to have 3 times, and let's do like this. My students showed me this thing about the left and the right. I didn't like it, so I borrowed it. 3 times this. So I'm replacing all my x's with a blank set of parentheses. 3 times 2x minus 4 equals 7 minus x plus 5. Okay? What goes into the blank parentheses? The 2. We just got x equals 2. We just got x equals 2. So the 2 goes into all those blank parentheses. The blank parentheses, what they do is, if there are negatives, it helps us to properly keep track of the negatives. Okay? So now we just want to simplify. You know. So like on the left, 2 times 2 is 4. 4 minus 4, so that's going to be what? 4 minus 4 times 3. The question is, does that equal 7 minus 7? Right? 4 minus 4 is 0, so then 0 equals 0. That's true. All right? So then we finish with the true statement, so it makes sense. So the answer of 2, it makes sense. It's a reasonable answer. When we plug it into the original, we got a true statement, okay? And we get the following. Let me pause for a moment and open the floor for questions. If there are no questions, you just go ahead and chime in and say, say we don't have any questions or we're good, so I know that you're listening. Any questions?
So all you did was just plug it in, right?
I just plugged it in. So now, I'm not going to go into all those details the entire time. This is just like the introduction, so I'm just trying to be thorough as an introduction. But going forward, it goes way faster. You know what I mean? But yeah, all we did was plug it in, and we finished with a true statement. So then, that's how that goes. That's the long and short of all that. Okay. Let's put you. Matter of fact, because I'm not using you right now. Nope. Yes. Sorry about that. Okay. So yeah. So we just plugged it in. We got a true statement. And it is what it is. Let me see the time. So we're going to kind of wrap this one up. We'll keep going. Okay, so let me move forward. Okay. So I think we got an answer of 2. And you see there, they got the same thing. They got x equals 2. And we finished with the true statement, so that's the solution. I'm going to work the next one. Yeah, just for the sake of time, I'm going to go ahead and do this one. And just stop me if anything is not clear or if I need to go back or slow down or anything. Let's go like this. So what I'm going to do is take this and drop it. And so all this stuff that you see me doing, one, these PowerPoint lecture slides are actually already on Moodle. And then the other thing is all the work that you see me doing, I'm actually going to load a copy and make it available in that box link that's on Moodle. So anything that you see me writing, you'll get a copy of it. So I just want you to write whatever you think is pertinent, whatever you think you need. But you definitely want to be taking notes like you're in class. Okay, and you want to take notes. Come on. Let's crop. I just want to get rid of. Oh, that's actually good. That's exactly what I wanted. Okay, cool. So let's give this one a go. I'm going to go ahead and do this one. I like to do my paper. I like to write on grid paper. It just is easy for me. And let's go like this. Boom. So in this example, we're asked to solve. We're asked to solve. Okay. So I like to start by getting a copy of the original. So we have this 2x plus 4 divided by 3 plus 1/2 x equals 1/4 x minus 7 by 3. Okay. So this is a copy of the original. My students in the past, they would draw this vertical line so they can make a distinction between the left side of the equation and the right side. I liked it, so I got this for my students, so I think it's fine. Okay, here's another question opportunity. I'm going to open this up to anybody. Let me check this thing over here. Look at the health of it. I think it's healthy. I think it's okay. Let's see. I see a yes. Okay, so we got a question. So if we look at this equation, we see we have fractions. Does anybody know a technique in order to get rid of the fractions and simplify this and make it easier? Does anybody know a technique that we can do to get rid of the fractions? Okay.
I was gonna say, all right, no, never mind.
Go ahead. What was the first thing on your mind? What was your first mind say? I'm just curious.
Well, the first thought until I saw the addition sign was reciprocal, and then I saw the variable, and I was like, I don't know if you could do that.
Okay, I get that. So I definitely encourage students to go with your first mind. The more you practice going with your intuition or your first mind, the more accurate it'll become. When you first start doing that, it's going to be wrong. But the more you do it, it'll become more accurate. If you're constantly second guessing yourself, what's going to happen is eventually you're going to second guess yourself out of the right answer. So whatever your first mind is, unless you know it's like, something else, just go with your gut. And the more you practice going with your intuition, the more accurate it'll become over time. The goal is, because I don't want people, because eventually if you always second guessing yourself, because this is what happened to me, if you always second guess yourself, you're going to second guess yourself out of the right answer, and then you don't want to be in that boat. That's not a good boat to be in. So the technique here to get rid of the fractions, what we're going to do, we're going to multiply the left side and the right side of the equation by the least common denominator of the denominators, the LCD. Can somebody identify the LCD of these denominators? What are our denominators?
You asked what our denominators are?
Yeah, what are our denominators?
The ones on the bottom, the
What?
3, 2, 4, 3.
Can you tell me the least common denominator or the least common multiple of the denominators?
Of what? Which side?
All denominators showing. So we have a 3, 2, 4, and 3. What's the least common multiple of all of those numbers?
1.
So that's like a common factor. Factors are smaller. A multiple has to be greater than or equal to all the numbers, right? So what's the least common multiple of all the denominators? Okay, so for instance, what's the largest denominator?
4.
4. Okay, what color are you feeling? Give me a color.
did you say?
Give me a color. Color.
Blue.
Blue. Okay. Give me a random object.
Square.
Give me an interesting random object.
Ice cream cone.
An ice cream cone. 12 is correct. So let's do this ice cream cone real quick. So what I'm gonna do for the ice cream cone, I'm gonna do kind of like this. I'm gonna go here, here, and then since the color was blue, I'm gonna do this. Actually, I'm gonna go right here. Do you mind muting your
Yeah.
And then that's better. I'm gonna go like this. And then one other thing. Did I miss? I sure did. And then I'm gonna just do this really quick. And that's okay. Matter of fact, let's go like this, like this, like this, like this. Okay, so this is our impromptu ice cream cone. What this is gonna do is serve as our cursor just to kind of draw attention as we kind of go. And then let's kind of go kind of like this. And about right there is good. Let's copy that and go like that. Okay, cool. So now, and I'm just doing this again for introduction purposes. It's gonna go much faster as we go forward. So to find the least common multiple of these denominators, since they're all numbers, let's start with the largest denominator, which is 4. Right? So then we ask ourselves, is 4 a multiple of 3, yes or no? Okay, is 4 a multiple of 3, yes or no? Okay, so 4 is not a multiple of 3. So then we say we multiply by 2. Is 8 a multiple of 3, yes or no?
Did you say 8?
Mm-hmm. Is 8 a multiple of 3, yes or no?
No.
So then we're going to multiply by 3. Is 12 a multiple of 3? 12 is a multiple of 3. 12 is a multiple of 2. 12 is a multiple of 4. And 12 is a multiple of 3. So that's one of the techniques to find the LCD. You take the largest denominator and you kind of work your way through the multiples. That's just one technique. I got that actually from YouTube. So the LCD, let's go like this, here, like here. So the LCD in this case is going to be 12, right? So what we're going to do, we're going to multiply all fractions by 12. We're going to say this times 12, like that. We're going to say this times 12, like that. We're going to say this times 12, like that. And we're going to say this, let me see. I'm going to do it this way. Hopefully we won't make a mistake with that negative. But we're going to basically multiply each term by 12. Just keep in mind that negative, let's rewrite that actually. We're going to rewrite this as plus a negative 7 by 3. So that way we can keep track of that negative. Okay. So now when we do this, 12 divided by 3 is 4. So then that's going to transform into 4 times that. 12 divided by 2 is 6. 12 divided by 4 is 3. 12 divided by 3 is 4. All right. So then the tops come down. We got this 2x plus 4 plus, what is that? An x is left over equals, I think an x is left there, plus I think the negative 7 is left there. Let's keep going. Okay. So now what this is called an equivalent equation, where it's just a multiple of the original and it's going to have the same solution set. So if we keep going, we can distribute the 4. And that's the only distributing going on. So then we'll get 8x, 16, 6x, 3x, and what is that? Negative 28. So then we want to combine like terms. 6 and 8 is what? 14x, 16, 3x, 28. Then we want to use the addition property of equality. So the thing that we introduced today, we're going to add negative 3x to both sides. And we're going to add this negative 16 to both sides. Okay. So then if we do this, This goes to 0. This goes to 0. 14 plus negative 3, that's going to be 11x. Negative 28 plus negative 16, negative 28, negative 38, negative 44. Okay. If we use the multiplication property of equality, we're going to multiply both sides by 1 over 11. 1 over 11. Okay, what time is it? Okay. And then so x is going to be, what is that, negative 4. All right. Just for the sake of being consistent, I'm going to check again. Be nice. Let me just kind of get a copy. So I want this stuff. Let me start over. I need this. I need that guy. I need this stuff. I do need that. I need this. I just need that guy. And I need this. Let's copy. I'm gonna paste. I think that's everything. And okay, so what we're gonna do, this is gonna be our check. And this stuff needs to be this color. All right, so let's do a quick check to see if it worked. I am going to check it actually. I mean, I guess I could do it by hand. I'll do this one by hand. I was going to show it in the calculator because you can actually put this in the calculator and check it, but I'm going to do this one by hand just for the sake of consistency. So then we're going to have 2 times x plus 4 divided by 3 plus 1/2 times x. Yeah, let me give me a moment. Let me be consistent. So let's go like, let's move it here. So we got an x there, 2x plus 4 divided by 3 plus 1/2 times x equals 1/4 times x minus 7 by 3. And what's our x in this case was negative 4. So negative 4 goes there, negative 4 goes there, negative 4 goes there, right? Okay, we're almost there. So then, let's see. So then 2 times 4 is negative 8. Now again, I'm doing this by hand. You can actually do this in your calculator. You don't have to do this by hand. This becomes what? Negative 2 equals negative 1 minus 7 by 3. So what is that? That's going to be a negative 4 by 3 minus 2 equals negative 1 minus 7 by 3. If we get a common denominator is 3. That one stays the same. That becomes a 6. This one becomes this. This becomes this. And again, this was all really just a question. And then ultimately we get negative 10 by 3 equals negative 10 by 3. That's a true statement, right? So because that's true, we can stand by our result that we got. Okay. So also, because this is like a live stream, we could always go back, watch the video, pause it, slow it down. You can ask questions, try to, get in there. I know it's a little bit what it is. Honestly, you're going to have to, now, this is the other kind of disclaimer I want to make. Trying to follow somebody else's math work is going to bore a hole in your head. Like, it's hard to do. I can't even do it. Like, I mean, I can do it, but you got to like really be patient. It's very difficult to follow someone else's work. The recommendation is take the original and do it yourself as best you can, right? And then you want to ask for help. You want to be frustrated for a little bit, and then beyond that frustration, then you want to ask to try to get support. But trying to follow what someone else is doing is going to be tough. The best thing is try to do it yourself and try to get assistance whenever you get stuck. And eventually you'll find yourself getting less and less stuck. But if you're only just following what I'm doing and you're not actively actually trying it, it's it's going to be a hard time. Usually that's a hard time. You have to kind of do the best you can on your own, and then just try to help get assistance to not be stuck too long. This experience is all about engagement. You know, you can't really learn it passively. You have to actually actively take it and go and do it yourself. This is an active thing. I'm just showing you that it's possible. As you kind of watch my presentation, you want to get ideas from me. But, you know, idealistically, you would have looked at this in advance. And then, you know, you can get tips and tricks when we engage. But otherwise, the only way you really learn is that you have to do it yourself. And just get help from others. You don't want to be dependent on others as best you can, but you know, I totally get it. Okay, so you just have to do your best, but do the best you can on your own. Okay, so we got a result. I think we got that -4 right there. Okay, so we got the -4, and then we checked, and we got the same thing. Okay, so stop me if you have any questions or if I need to go back to anything. Otherwise, I'm going to press forward. What's today? Today is Thursday. Okay. So I kind of do want to move on to the next section. I'm going to do a quick glance to see if there's anything pertinent. So let's do a quick discussion on what we mean by identity, conditional, or contradictions. An equation satisfied by every real number is called an identity. So let's just solve this one really quickly. So for instance, if we distribute, right, we'll get 3x plus 3 equals 3x plus 3. If we subtract the 3x on both sides like this and subtract 3 on both sides like this, we'll finish with basically 0 equals 0. Notice that's a true statement. Notice also that the variables are gone. So when our variables go away and we finish with the true statement, this is called an identity. What this means is that any real number is going to work in the original. Right? This means that any real number is going to work in the original. That's called an identity. Okay. All right. Conditional, and again, there are infinitely many solutions. So any number on the real number line is going to work there. A conditional equation, like if we solve this and if we divide both sides by 2, x is going to be equal to 2. All right. Conditional means that this equation is true based on the condition that x equals 2. So an equation that's satisfied by some numbers is what we call a conditional equation. And then a contradiction, if we were to solve this one, say we subtract the x on both sides, we finish with 0 equals 1. This is false. So notice that the variables went away, the variables canceled or disappeared, and we finish with a false statement. We finish with the false statement. So this means that no real number is going to work. This is an example of a contradiction. Okay.
I have a question.
Sure.
Okay, so identity is when both sides equal the same.
It's true.
And it's true. And conditional is when it's like x equals 2.
Right.
Like anything like x equals 5, x
Right.
equals 7.
Right.
And then a contradiction is when it's false.
Right.
Like 4 equals to 20.
Right. Something like that.
Okay.
So the variables are gone and you finish with the false statement. That's fantastic. Why is everything chrome? Because of LeBron James? Did something happen to LeBron James or was that a joke? Anyway. All right, let's keep it moving. All right. So let's keep it moving. Oh, so we're actually identifying. I'm going to leave this as an exercise actually because I would like to move on to the next section. I do want to at least do 1, 2 today. So I'm going to leave this one as an exercise. I'm going to leave that one as an exercise. So with these examples that I'm skipping, what you want to do is still take the original. Again, the suggestion or the recommendation is to replicate, simulate, or duplicate the testing environment. Like if you get a question, we don't want to jump straight to the answer because whatever we practice, that's how we're going to do on the exam. You know, so on the exam, we're not going to have the answers. So you know, you want to do your best. Just take the original question with as little support as possible and see can you arrive to the answers correctly. But I'm leaving these examples as exercises because I know that you all can handle them. Okay. And if you have a hard time going through these, reach out to me and I'll do a dedicated video walking you through any of these questions. With a contradiction, that means no real number is going to work. This symbol is called the null set. It means the empty set or no real number. This is called the null set. So when we get a contradiction, we say that the solution set is the empty set or null set. That means there's no solution. So when we solve formulas, like this is a formula for simple interest, I equals PRT. Like for instance, this example says solve for T. When we solve a formula for a specified variable, what we want to do is imagine that the other variables are numbers. Just treat them like a number. And treat the T in this case like the X. So like if we had 6 equals 3X, the same way that we solve 6 equals 3X, we solve this one that's shown on the screen right now. Where if it was 6 equals 3X, we would divide both sides by 3. In this case, we would divide both sides by PR, right? So whatever variable we're solving for, we treat that like X, and we treat all the other letters like a number. And however we would solve if it were a number, we do the same thing for stuff like this. Okay? I'm totally about to fall asleep. We're kind of getting into like our home stretch. I'm trying to think of an activity that we could do and engage, but I can't think of anything right now. This is more solving. I'm going to have to leave this one as an exercise. Give these examples a go. If you can't figure them out, contact me and I'll make a dedicated video walking you through any of these examples. Okay? I'm going to leave all this as an exercise. Yeah, I'm going to leave this. You can definitely handle all this. So what I'm going to do, I'm going to go ahead and load these notes for this section into our box folder that you can access through Moodle. Let me see. So the location, this is the spring. This is actually College Algebra. And to the notes, handwritten notes, we want to put it there. Okay. Page is at 11. I guess that doesn't. Well, let me shrink that down. Page 11. Give me just a moment. Okay. I think the rest of this is fine. I'm not going to worry about all that. Let's share, send it to box. I'll get rid of that one. Okay. Yeah, that's the right one. Okay. So when this bar finishes loading, you'll actually get a copy of all the handwritten notes that you saw me doing. You'll get a copy into our shared box folder. And then I'm going to pause for like a few minutes, just long enough to update the title, and I want to go ahead and do a live stream for section 1.2. We'll do the best we can for section 1.2. Whatever we don't finish in this next 50 minutes, you're going to be responsible for your own. If you need me to go through any example, I can make dedicated YouTube videos. I'll walk you through anything that you want that's in the course, right? We do have work. I went on and loaded what we're responsible for the exam for next Thursday. Okay, and we're going to be on the lookout for a quiz, right? So I loaded the homework for exam 1 on Pearson, and you want to kind of go ahead and take advantage of that. Okay. So give me a moment to just kind of shut the stream down, and I'm going to go ahead and prepare for the next section. So I'll be back in like about 5 minutes. You can take like a quick 5-minute break. I'll be right back. All right. And so on that note, let's go like this. Let's go here and let's do like this. We want to add a page just to kind of close it like that. And so again, we're going to end on this note. And so from one beautiful mind to another, enjoy the rest of your day. Not you guys. I'm going to be right back. But I'm just talking to like anybody else that might be watching. I'll be right back. Peace. All right.